Unit 5, Video 6, Factoring Shortcuts. We're going to talk about two different styles, difference of squares and perfect square. So difference of squares looks like this. Like here's an example. If you had the parentheses x minus 2 times x plus 2, this equals x squared minus 4. And I'll show you down here with the box method that we learned previously. So you would have your x minus 2 and your x plus 2. And when you multiply them, you get an x squared in here. You get a minus 2x up there, a plus 2x down here, and a minus 4. Well, when you do your combining like terms, the in-between step looks like this. X squared minus 2x plus 2x minus 4. Well, that minus 2x plus 2x cancels out, which is why you're left with x squared minus 4. So if you can see that right away, you have a square, a perfect square in your first term, and a perfect square in your second term, and there's a minus sign, then you can jump to this type of factoring. Okay, so to factor, you take the square root of the first term and the square root of the second term. One gets a plus sign and one gets a subtraction sign. So let's factor x squared minus 16. Okay, well, I know without even doing the box method, and I can do the box method for this, I am taking the square root of this first term. Well, the square root of x squared is simply an x. So that's going in the first place. Then I'm going to take the square root of the last term. Well, the square root of 16 is 4. So I'm going to put a 4 there. And then finally, it says up here, one gets a plus sign, one gets a subtraction sign. That is this. Minus, plus, or vice versa, plus, minus. Again, we can do a quick check and multiply this through, and you would get x squared minus 16. Okay, here's another example. X squared minus 25. So I go straight into my two parentheses because I've already determined that x squared is a perfect square, 25 is a perfect square, and I have that minus sign in between. It will not work if you have a plus sign here. It will only work if this is a minus. Thus the name difference of squares, okay? So the square root of x squared is simply x. So I put x in the first position of both of them. The square root of 25 is 5. So I put a 5 here. And then like I said, one gets a plus, one gets a minus. It doesn't matter which side you put the plus, which side you put the minus. But that's because it could also be x minus 5 times x plus 5. Those are the exact same thing, okay? All right, now we're getting a little more tricky. Same rule applies though, okay? So right away, I can go with my two sets of parentheses. I'm looking at what is the square root of 4x squared? Well, what is the square root of 4? The square root of 4 is a 2. As we've done on the previous two problems, the square root of x squared would be an x. So instead of this being just an x in the first place, it's a 2x. The square root of 36 is simply 6. And again, one gets a plus, one gets a minus. Now, you might be saying, hey, I can pull out a 2 on both of those, and you can, and we're going to talk about that in the next problem. Right now, we're going to leave this right here, even though you can see I have a 2 and a 6. So there's a 2 in common here, there's a 2 in common here. Think about that one when we're thinking of greatest common factor. Now, you might be originally looking at this problem saying, nope, 3 is not a perfect square, 27 is not a perfect square, this can't be done that way, it's not factorable, etc. However, there are problems that look exactly like this that would go, wait a second, is there a greatest common factor that I can pull out? Something that's in common between a 3x squared and a 27? Well, there is. I can instantly pull out a 3 from this, so I am dividing off a 3. When I divide off a 3, I'm left with an x squared and a 9, because 27 divided by 3 is 9. And we know this because if we did distribution, we would find out this would be 3 times x squared, which is 3x squared, 3 times 9, which is 27. Now, this is a perfect square, this is a perfect square, and you have the minus sign. So we're going to keep going. We're going to leave the 3 on the outside, set up my two parentheses, okay? X is the square root of x squared. 3 is the square root of 9. one gets a plus, one gets a minus. So this one just looks a bit longer, and you need that 3 just chilling on the outside so someone could get back to this original equation if they wanted. But this would be your final answer. All right, so I just made it even a larger type of concept. So again, you're still starting out with your parentheses. Right now, 4 and 81 do not have anything in common, so I can't pull out something between the two of them. So now I start doing my square root game. The square root of a 4x squared is a 2x. So I write that in the first position. The square root of an 81y squared, and I wanted you to see this, that this could also be on the second term, the variable squared. It's just a different variable. The square root of that would be a 9y. So you're doing it the same way. It's just a matter of its location. One gets a plus, one gets a minus, and you're done. So it's not that scary. It just had larger numbers and extra variables sitting on both of them. Okay, perfect square, I'm giving you an example, is you can see it in these two forms. Either you see the parentheses squared, or you're going to see it look like this. So we're still going to play in the game with square roots. Okay, so I'm still going to put 2 sets of parentheses. And I'm going to take the square root of my first term, okay, which is an x, and I'm going to put that in the first place. I'm going to look at the square root of my last term, which in this case is a 2. And when I'm talking about perfect squares, I'm going to look at the value of my middle term. Since the value of my middle term is a minus sign, I'm going to put a subtraction sign in both of those. Thus my perfect square. Now, let's do a check of this real quick just to make sure we did our math correctly. So here we go. We make our box. X minus 2, x minus 2. This becomes x squared. This is minus 2x. This is minus 2x. And this is a plus 4. So we get x squared minus 4x plus 4, which, yes, indeed, matches our original equation. Okay? But we could also do this problem easily right here with the box method, our backwards box method of factoring. It would totally work as well. Okay, so again, drawing my parentheses, taking the square root of the first term, square root of the first term, and this problem is x, taking the square root of that last term, square root of that last term is 3. Okay, looking at the sign in the middle here, since it's a positive, I should have a plus and a plus. Again, let's do a quick check of this. We have x plus 3, x plus 3, and here you get x squared plus 3x plus 3x plus 9, which gives you x squared plus 6x plus 9, which is the original equation. Okay, so this just has a little bit larger numbers, but no problem. Same steps apply. We're going to take the square root of 4x squared. The square root of 4x squared would be a 2x, because 2x times 2x equals a 4x squared. We're going to take the square root of 9. The square root of 9 would be a 3. And then we're going to look right here and say, okay, what's that sign? It's a plus sign, so that means we have a plus and we have a plus. Again, I like to do the quick double check because it doesn't take me long to do it. 2x plus 3, 2x plus 3. This gives me a 4x squared. This gives me a 6x, 6x, and a 9, which gives me 4x squared plus 12x when I combine like terms, plus 9. Fantabulous. They are the exact same. So basically the gist with this is these are two shortcuts that, yes, if you recognize them, they can speed up your process of factoring. But if you don't, you can still do them the old way that we learned. So even like this, the x squared minus 25, if you were doing the box method, you would still start out with x squared here, minus 25 there, and your goal for these two terms would be the factors that when one is a positive, one is a negative, they cancel out. Well, we know right away that that means one has to be a 5x and one has to be a minus 5x, because again, if you would add them together, they would go away, and then you're still doing your same process. You're pulling out. So you'd have an x here, you'd have a 5 there, you have an x here, and you'd have a negative 5 there. So it would still factor to x plus 5, x minus 5 as your two-factored form. Same thing, just a different style.